Hello everyone, this is Tom from TutorBros. Today we're going to go over the triangle midsegment theorem. Now this is an interesting theorem because it tells us a few different things all at once, but first let's just define what a midsegment is. So the midsegment of a triangle, and in this diagram it's just going to be this line right here, is the line that connects two sides of a triangle at their midpoints. Note that a midsegment can be drawn between any two sides of any triangle, but for present purposes we just drew the one. So the first thing to say about a midsegment is that it cuts each of the two sides of the triangle that it touches in half. So we can say that this segment here and this one here are equal, as well as this one and this one. Another characteristic is that the midsegment is always going to be half the length of the third side of the triangle. So the midsegment is always going to be 1/2 this side right here. And then the last thing to mention is that the midsegment is also always parallel to the third side of the triangle. So I'll draw the arrows here to indicate that this segment and this segment are going to be parallel to each other. All right, now that we've got all that straight, let's do some example problems. I'll just erase some of this extraneous information here. Oops. Let's see. All right. Okay, so for the first example, we'll say that the midsegment is 8 units long, and then we are asked to find the length of the third side of the triangle. So just remember that the third side of the triangle is always going to be double the length of the midsegment, where we can say that the midsegment is half the length of the third side of the triangle. However, it helps you to remember that relationship is fine. So since we know the midsegment is 8, and the third side of the triangle is double that, we just double 8, and that'll tell us that x, or the length of the third side, is equal to 16. Easy enough, no tricks there, so that's one problem down. Okay, so we'll erase that. Okay, now let's do another one that includes a little bit more algebra. So we'll say this time that the midsegment is represented by the expression x plus 3, and the third side of the triangle, its length is 3x minus 5. And then here we're just asked to solve for x. Now remember again that the relationship between these two segments is this. The third side of the triangle is double the length of the midsegment. So we can say that 2 times the midsegment, which is represented with the expression x plus 3, is equal to the length of the third side, 3x minus 5. So now we've just got a simple algebraic equation. We'll do some simplifying and we'll solve for x. First thing I want to do, of course, is distribute the 2 on the left side, so that's 2x plus 6 equals, we still have 3x minus 5. We'll subtract 2x on both sides, so 6 equals x minus 5. And then we'll add 5 on both sides of the equation to get 11 equals x, where x equals 11. Alrighty, so that's all there is to that. Now let's do one more example problem. This one's going to be a little more comprehensive. It's going to incorporate all the different aspects of the triangle midsegment theorem. So let me get all this information out of here, and we'll start from scratch. Okay. All right, now for example 3, we're going to say that the midsegment is 2x plus 3. The length of the third side of the triangle is 7x minus 3. Okay. Now we're going to add a little bit more information. We're going to say that this angle right here in the bottom left-hand corner is going to be 75 degrees. And then we'll also say that this angle right up here is, I'll write it out here, y plus 2 degrees. Okay, so I'll draw a little arrow here. Alrighty, and then the last piece of information I want to add is that this segment here from the top to down to the mid segment will be represented with this expression 4z plus 20. And then from the mid segment down to the bottom of the triangle, this will be represented as 9z units. So now our task is to just find the value of all of the variables, x, y, and z. So we'll start with what we know. We'll do the x value first. So one more time, can't stress it enough that the triangle, the length of the third side of the triangle is going to be double the length of the midsegment. So we can say that 2 times the midsegment, which is 2x plus 3, is equal to the length of the third side of the triangle, which is 7x minus 3. And then we do the same as before, where we distribute. So we have 4x plus 6 equals 7x minus 3. Subtract 4x on both sides, so 6 equals 3x minus 3. Add 3 on both sides, 9 equals 3x. And then divide both sides by 3, so 3 equals x, or x equals 3. So now we found the value of x. So let's move on to the y and the z. So let's take a look at the angles first. Now, what's the relationship between these angles? Well, they're both sitting on top of the midsegment and the length of the third side of the triangle, respectively. And remember that those segments are parallel to each other. And we can think of the side of the triangle on the left-hand side, or on the right-hand side, as being a transversal that cuts through these parallel lines. So that would make these angles corresponding angles. So they are in the same place on each respective line in relation to the transversal. So since they're corresponding angles, we can say that they're equal to each other. So then we can just say simply that y plus 2 is equal to 75. And then we just subtract 2 on both sides. Y equals 73. Okay? Nothing too difficult about that. And then the last variable we have to solve for is the z. So what's the relationship between these two segments that we've identified? Well, the 4z plus 20 and the 9z are both portions of the same side of the triangle on the right. And we know that those two segments have to be equal to each other because they're cut in half, perfectly in half, by the midsegment. So we can simply say that, I'll write this over here, 4z plus 20 is equal to 9z. And then we just solve for z. First thing we do is subtract 4z on both sides. So 20 equals 5z. And then divide both sides by 5. So 4 equals z. And there we have it. We've solved for each of the variables in this diagram using all the different properties of the triangle midsegment theorem. So x is equal to 3, y is equal to 73, and z is equal to 4.